Can you hear me now? Okay. Hello, thank you very much. So, have you or your employees ever needed important instruction while performing an important maintenance task? Or perhaps, have you ever wondered what a piece of art meaning was while staring at a statue or whatever? Well, I did for many reasons, not just because of my job, as you will see, but because we, as human beings, interact with reality always, continuously. And asking questions about reality is what we human beings do. So today, I would like to talk about how augmented reality can help to make our lives better from this point of view. And to this regard, I will also talk about specifically about object tracking, so the most advanced achievement from this point of view. And finally, I will talk about some important use cases that make that help us to describe how augmented reality effectively can help us. So, depending on your background, your job, or your interests, you may know or not what augmented reality is. So basically, I would like, first of all, to define augmented reality, because if you look for augmented reality on the web, this is what you will look for, you will find. And actually, this definition is not 100% complete. Indeed, it is just 33% complete, if you want. But a more complete definition of augmented reality has been given by Ronald Azuma in a survey on augmented reality, and basically it says almost the same thing as the previous definition, but a little lines later in his survey, he adds that an augmented reality system actually has three major components. The first one requirements that augmented reality systems must combine the real and the virtual, and this is the same thing that we have seen so far. But also, it must be interacting in real time. This meaning that all the action for the end user must happen in real time, not like it happens, for example, with visual effects like we see in movies. And most importantly, another characteristic of the augmented reality system is that it must be registered in 3D. This meaning that an object that you display using a smartphone or a smart glass must be strictly attached to the reality. So if you move, the object stays in place and doesn't float or somewhere, or it's just fixed on your point of view. For the sake of completeness, we also can talk about a mixed reality, because lately this is something that is coming out more frequently. And the mixed reality actually is a wider concept than augmented reality. If you look at this scheme, you see that augmented reality is just a part of mixed reality. Mixed reality actually entails everything that comes from the reality and overall, to virtual environments, so virtual reality, but does not include both virtual reality and the real world. And so basically, augmented reality is just a specific case of mixed reality. But look at this picture. We are all used with this kind of blockbusters and movies and visual effects. This may look like augmented reality because we see the T-Rex exactly there, and we have we think that Tyrannosaurus Rex is there. But actually, what is missing? Why this is not augmented reality? This is not augmented reality because it's not interactive. It's missing one important thing: interactivity in real time. And specifically, to create this kind of image, you will need very, very power computers, specifically render farms. And so just to create one single image for this kind of visual effects, you will need a lot of time. Whereas, when talking about augmented reality, usually you have to create real-time computer graphics, and you have to do it eventually on smartphones or eventually on other devices that have very little computational powers, like smart glasses. So the requirements are very different, especially if you think that what happens with the augmented reality is that the hardware and software must, in a way, understand the reality. And also, it must be done continuously for 30 or 60 times for each image. Fortunately enough, the hardware evolution helped us a lot from this point of view, because starting from 5 or 4 years ago, the performances of CPUs also on mobile devices improved a lot. So we managed to have very interesting things also on mobile devices. Just sum up the differences among these kind of technologies. So we say that augmented reality has these characteristics, and what makes it different from mixed reality system is the fact that in augmented reality system are registered in 3D, so the objects are exactly there, whereas mixed reality system are more relaxed from this point of view. Whereas regarding mixed visual effects system, what is missing is the interactivity in real time. As I told you, what is really, what happens behind the scene for augmented reality system is an understanding of the reality, and this must happen continuously. And this is a very, very strong requirement for augmented reality system. And one may think that basically the understanding of reality could be just some algorithm that look an image and try to find out what's happening. But actually, in order to achieve real-time performances, we must rely on at least two kind of processes. First, recognition, understanding where an object is, and eventually also understand how the camera is positioned with respect to that object. But to have real-time performances, we have also an important task that is usually called tracking. So basically, we try to find some important features in a smart way and not on all the image, for instance. And this allows us to run at 30, 60 frames per second, for instance. Basically, to do this kind of things, so to understand the reality, we rely on sensors. Then either common sensors or camera, anyway, are also sensors by themselves. And using camera-based methods, you can track and recognize markers, as we will see, or images like posters, blueprints, or the environment itself, or objects. And this is what we will focus in a while. But you also can rely on sensors. For instance, if you want to track the user position on Earth, or you can use, oh, sorry, I just skipped away. Here it is, sorry. I was saying locations or the inertial measure units, so basically the orientation of the device in space, or also mechanical sensors that allows you to have very accurate positioning of a device, or electromagnetic and acoustical methods. This is an example, for instance, of a marker-based tracking. And the problem with this approach is that they are, actually, one of the advantages is that they're very, very fast. Indeed, it's one of the first techniques that was used in the early days of augmented reality. Also, you can understand that there is something, and so they are very noticeable, and you can understand that something will happen if you look at this kind of things. Sorry, they have some problems. For instance, they are very ugly, and if you want to make a marketing campaign, for instance, for a good-looking object like a car or something else, it's not very good to use these kind of objects. And another problem is that they're very sensitive to lighting changes. So if they have shadows on top of them, they will stop working. Or if you cover an edge of the black square, it won't work anymore. But Another problem is also that they are noticeable because they're very eye tracking, and so it doesn't make sense to use them everywhere. Another approach that is usually better is based on images. And in this way, you can track and recognize features on generic images, so posters, blueprints, and the likes. So they're usually nice to use, and the user won't complain about it. They're also fast, so they can be used on mobile devices as well. And they're less sensitive to light changes with respect to the previous technology. And they also have quite tolerant behavior with respect to occlusion, so you can cover the page, for instance, of a newspaper. And you don't notice that there is something special with this kind of images. So this is actually also a problem, because you have to tell the user that there must be something happening on that page, so you have to use also stickers to trigger the augmented reality, actually. And also another important kind of method to understand reality is based on what is called simultaneous location and mapping. It's SLAM approach, actually. And it allows you to scan the environment you are in and to create a map of the environment. Actually, this kind of approach is quite fast, so it's usable also on mobile devices. And it handles occlusion, so you can also move in the environment and not affecting tracking too much. You don't know that something is in that environment, so there must be some mechanism to tell the user that something happened there, but this is not really a problem, actually. And one problem is that you have to make some specific movements to start tracking and recognizing the environment. And it's called usually a SLAM dance, exactly. And if lighting change in the environment, the map that you have created may not work anymore. Also, a problem with this approach is that if you use it just as is, you won't have any information about the size of the environment that you are scanning, so you have to add other information. And you cannot recognize a specific place or an object in this way. It's very difficult. Another tracking method that we have mentioned is location-based tracking, but basically this method is it's still very fast. It relies on the GPS and the IMU unit on your devices, so the compass and gyros and so on. And also, it does not have any problem with light changes, because it relies not on vision, computer vision, but just on sensor installed on your device. And it works very well with objects in the distance, not objects really near to you, very close to you, because of the errors of sensors. So you know that you use GPS, the position can change, and this is not very accurate. You could have 5 meters errors, so it doesn't work with close distances, but just long distances. But it drains your battery, and actually, this should be in the other list, you can manage occlusion because you are not using computer vision. So you can also pass through in front of an object, and you will see the object in augmented reality as well. Usually, for this kind of things, they are using with balloons like this to highlight some spots, but this method doesn't work very well if you want to, for instance, display some object in front of that church and have this object stick to the church itself, because you see that sometimes the content moves and floats in the air. Yeah, this jittering problem. Also, the sensors are usually very noise dependent, so if you have electromagnetic fields nearby, the GPS won't work very well, or the compass and things like this. One of the most important achievements in computer vision tracking is object-based tracking, and this is what I'm going to describe better. The good thing about this approach is that it works in real-world scenarios. So this makes this method employable in real-world scenarios. Somehow it does not